Hello everyone, today we're going to look at part 2 of logarithms. So we're going to solve exponential and logarithmic equations. So solve the following for x. If necessary, round to the nearest hundredth. 6 to the x plus 1 equals 120. So since our unknown is in the exponent, we want to change this to a logarithm in order to solve. So our first step, change it to a log. Remember the base is 6, so it's going to be log base 6 of something equals something. The log equals the exponent. The exponent is x plus 1, so 120 has to go inside the log. So log base 6 of 120 equals x plus 1. To find log base 6 of 120, we're going to use the change of base formula. So remember that's ln of 120 over ln of 6, or we can do the same thing with log 120 over log 6. Because it says to round your answer to the nearest hundredth, you're always going to want to do more than that many decimals if you're in the middle of a problem. So since we're in the middle, I'm going to go to more than 2 decimals. I'm going to go to 4 decimals. So I would always suggest doing at least 2 more than what it says to round your answer to. So log base 6 of 120 is 2.6720. That's x plus 1. To solve for x, subtract 1 from both sides, and then round to the nearest hundredth. So I subtracted 1 and then rounded to 2 decimals. You can always check it by plugging it back in. It won't be exact because we did round, but it should be fairly close to 120. 2 to the x equals 3 to the x minus 2. So in this case, we have 2 exponent variables here. We've got an x and an x minus 2. The easiest way to solve these is to take the log of both sides. So it can be either log, which is log base 10, or ln, log base e. You just want to choose one of the two that you have in your calculator. So I'm taking the log of both sides. The next step is to use the rules of logs and bring down my exponents as coefficients. Be careful, x minus 2 is a binomial. Make sure you have it in parentheses. That whole thing is being multiplied by log of 3. The next step that I'm going to do is I'm going to divide both sides by log of 3. I'm choosing the one that's being multiplied by the binomial, and that's just going to make things a little nicer. I don't have to distribute later. So if one of your exponents is a binomial, divide by that log. Okay, but it really doesn't matter. You could divide by either one. But again, if you divide by the one with the binomial, you don't have to worry about distributing anything. So divide both sides by log of 3. This I can plug right into my calculator. And again, I'm going to go to 4 decimals because I'm in the middle of a problem. So I have x minus 2 on the right, and I have 0.6309x on the left. And then to solve, we just continue with our problem. I'm going to subtract x over here, and then divide by it to get x by itself. Okay, so it's just basic solving a linear equation that you did in 110 or 100 or 105 at this point. You just have some decimals. So x should be 5.42. And again, you always want to check it by plugging it back into your equation. How about ln of 20 minus ln of x equals ln of 30? So now we've got a logarithmic equation. These are really broken down into 2 types. Either every single term is a log, or there's at least one term that isn't a log. So in this case, all of my terms are ln of something, so they're all logs. And what you want to do is you want to simplify each side into a single log. So the right-hand side is already a log, ln of 30. The left-hand side, I have 2 logs that are separated by subtraction. So I'm going to use rules of logs with subtraction to combine them. And I'm going to end up with ln of 20 divided by x on the left-hand side. Now that I have a single log equals a single log, no coefficients, right? these are both 1. I am going to cancel the log and kind of undo that first step that I did in the previous problem. So I've got log of both sides. Now I'm going to cancel the logs, and I've got 20 over x equals 30. But again, I can only do this if I have 1 log equals 1 log. That's the only time I can do it. And the logs have to be the same base too. Now again, it's just a question of solve this for x. So you want to multiply both sides by x, divide both sides by 30. 20 divided by 30, simplify it, 2/3. Now remember, with logs, you have to make sure that what's inside the log is positive. So can I plug 2/3 into this? Yes, because it's positive. Okay? And it's not that x has to be positive, it's that what's inside the log has to be positive. So for instance, if I had ln of x minus 1, I cannot plug 2/3 into that, because then I would have ln of negative 1/3, and that's not a real number. Okay, so you always have to go back and double check when you've got a logarithmic equation. Exponentials, I can plug anything I want into an exponent, so I got to be careful with the logs only. So let's try another one. Log base 3 of 2x minus log base 3 of 8 equals 4. So I have here a term that does not have a log. And if that's the case, I want to put my constant on one side and all my logs into a single log on the other side. So just like before, I've got a log minus a log. I want to simplify that using division. So 2x divided by 4 is x over 4. 2x divided by 8 is x over 4. Now I have a log equals a number, and I'm going to just translate it back into exponential form. So my base is 3, my exponent is 4, and it's going to equal my x over 4. So 3 to the 4th equals x over 4. And then I solve it. 3 to the 4th is 81. So 81 equals x over 4. Multiply both sides by 4, and we get 324. And again, the question is, am I allowed to plug that in? Yes, 2 times 324 is positive, so I can plug it in. Let's do another one. 3 to the 2x equals 5 to the x minus 3. So again, I have 2 exponents, so I'm going to take the log of both sides. So log of 3 to the 2x equals log to the log of 5 to the x minus 3. Use rules of logs, bring down my exponents. Again, I'm going to put my x minus 3 in parentheses. And then again, I'm going to divide both sides by the log of 5. And I'm choosing that because of my binomial of the x minus 3. So on my right, I've got x minus 3. On my left, I have something times x. And that something is 2 times log of 3 divided by log of 5. So I want to do that all together and just have one number times x. And again, I'm going to round to 4 decimals because I'm in the middle of a problem. So 1.3652x equals x minus 3. So again, the next step is to subtract x from both sides. So 0.3652x equals negative 3. Divide by my decimal here, my coefficient. And I get that x is negative 8.21. And again, you always want to check your answer, plug it in to both sides. Make sure you're getting roughly the same thing. Again, it is rounded, it won't be exact. And let's try our last one. Log of x plus log of 7 equals 2. We have a term that's not a log, so we're going to combine our left-hand side. We've got addition, it's going to combine as multiplication. So log of 7x equals 2. Then we're going to translate it back into exponential. Remember, if there is no base, it's base 10. The log equals the exponent. So 10 squared equals 7x. 10 squared is 100. Divide both sides by 7. And we're getting x equals 14.29. And again, I am allowed to plug that in because it's positive. Okay, so make sure you read through the book, make sure you try out the problems, and let me know if you have any questions. Thanks.